Hello everyone. So today we are going to be talking about another problem. Okay, so that's a part 2 question. Okay, in which we already know how we can detect a cycle in linked list. Okay, but now we are going to be finding the node from where the cycle starts. Okay, so basically the junction point. Okay, so here just read the description. So given a head of the linked list, return the node where the cycle begins. Okay, if there is no cycle, return null. Okay, so there is a cycle in linked list if there is some node in the list that can be reached again by continuously following the next pointer. Initially, internally, basically, position is used to denote the index of the node that the tail's next pointer is connected to 0 indexed. Okay, minus return -1 if there is no cycle, and note that the position is not passed the parameter. So we need not to worry about position is used internally. Okay, so let us see the example here. So example is 3 2 0 -4. So this is the linked list which is there is a cycle in there. It starts with the cycle with the position 2. Okay, and we have this position value 2, position is 1. Okay, it is internally position 1. Now we need to return this value this node 2 itself, because this is the position this is the node from where the cycle starts. Okay, so output is still connected to the node index 1. Okay, so this node, and there is a cycle in the linked list. Another example is 1 2. So there is a cycle. It begins with the value with the index 0, position is 0. Okay, and tail connected to the node index 0. Okay, so there is a then again the value is the node is 1. Okay, so there is no cycle possible. Okay, so that we already discussed. Now the number of the nodes in the linked list can range from 0 to 10 to the power 4, and the value can be from -10 to the power 5 to 10 to the power 5. Okay, and position is -1 or the valid index of the linked list. Okay, so we are trying to be doing this problem in order of one memory. Okay, so let us try to solve this. So before jumping to the solution, let us try to I will explain the code first. I'll explain the flow first, and then we'll be seeing the logic behind that. Okay, so what we are going to be doing first, our process. So there are two steps basically for this. So finding the collision point, first we are going to be finding the collision point. Once we know the collision point, we will be traversing from both the side, and will be meeting to the junction. Let us see the example and we can understand better. So suppose we have two pointers, one is fast slow pointer, another is fast pointer, and we already know how we can detect the cycle. So we are going to be doing that. First we are going to be finding the position where they meet. Okay, so how we are going to be doing that? We are going to be moving the fast pointer by 2 positions and slow pointer by 1 positions. Okay, so slow pointer, both of them are pointing to the head initially, but now we are going to be moving this fast pointer by 2. So fast pointer will be coming from here to here, and slow pointer will be coming from here to here. Okay, then again fast pointer will be jumping 2 positions. So fast pointer will be coming here, and slow pointer will be coming at this position. Now again fast pointer will be jumping 2 position, it will be coming here, and slow pointer will be coming here. Then fast pointer again will be jumping 2 positions, and slow pointer will be jumping 1 position. Then again fast pointer will be jumping 2 position, slow pointer will be jumping 1 position. Then again fast pointer will be jumping 2 positions, slow pointer will be jumping 1 position. Okay, like this it will continue. So fast pointer will be jumping 2 position, it will be coming here, and slow pointer will be coming from here to here. So you can see this slow pointer have met the fast pointer at this position. Now the first step has been completed. Now what is the second step? The second step is to move start from the head again. We can call that pointer as entry pointer or any other pointers. So this entry pointer is here, and we have the slow pointer here. Okay, now we are going to be traversing both of them, and we'll be seeing where they can meet. Okay, so we'll be moving our entry pointer from here to here 1 position, slow pointer from here to here 1 position, then again 1 position here and 1 position here. So you can see both the entry pointer and slow pointer have met. So the position where they have met is our junction. Okay, so we are simply going to be returning this node. Okay, so that's our answer. Okay, and now let us discuss why they are going to be meeting for sure, and what's the logic behind that. Okay, so we are going to be discussing that. Now let us try to understand the logic behind that. So here we have, suppose we have slow pointer, we have fast pointer, which are pointing to the head. Okay, and suppose this is the L1 distance from starting to the junction point. Okay, and let us assume that the slow pointer has traveled L2 distance. This L2 distance is not a distance from here to here, it is the overall distance where this position, where the slow pointer and fast pointer meets. Okay, so it can take one rotation or two rotation, but the L2 is the total distance that is been traveled by the L2 in this cycle. Okay, I hope that is clear. Now again, we have this, the slow pointer have traveled how many distance? L1 is for sure plus L2. Okay, so that is the distance traveled by the slow pointer, but fast pointer must have traveled some more extra distance. So let us assume that distance as NC. What is NC? N is the number of rotations and C is the cycle of C is the length of the cycle. Okay, so NC distance is this one. We know that 2 of S is F, because we are jumping 2 positions for the fast, and slow pointer jumps only 1 positions. So we have 2S equals to F. When we try to equate them, so 2L plus 2L1 plus 2L2 is equals to L1 plus L2 plus NC. Okay, and then we just try to solve that. We come up with this solution that L1 is NC minus L2. Okay, so if from NC, if we just remove this L2 distance, we'll be having L1 distance. So this distance becomes L1 from the position where we meet up to the junction becomes L1. So what we can do after that, we can make the entry point of starting from here, and then our slow pointer is already here. So from here we can start jumping one position, and we are sure that we are going to be meeting both of them entry will be meeting at the junction point. So that is the approach. So suppose here only 2 jumps are there, so from here also only 2 jumps will be there. Okay, so this node will not be there, so only 2 jumps will be meeting here. So that is the basic idea between this approach. Now let us see the code. The code is very simple. Whatever we discuss, we are simply writing here. So we have 3 pointers. We have slow pointer, we have fast pointer, and we have entry pointer. Okay, entry pointer is pointing to the null, and a slow and head pointer, slow and fast pointer are pointing to the head initially. Now what we are doing, we are just doing the same thing which we did for the detecting a cycle and linked list. We'll be having this condition that fast should not be null and fast.next should not be null. Okay, we can even keep the condition of fast.next not be equal and fast.next not be equals to null. Okay, but this will also be working fine. Now when we open this, okay, so we'll be making slow pointer jumps 1 position and fast pointer jumps 2 positions. Okay, first we'll be doing the jumping part. Now after this, what we are doing, we are checking that if our fast is equals to slow. Okay, if our fast is equals to slow, then we are going to be doing the part which we are jumping one position from both our side. Okay, entry position will also be jumped by one position, and the slow pointer will also be jumped by the one positions. Okay, so whenever we have fast equals to slow, the first step has been completed. What was the first step? The first step was to find the position where they meet. Okay, first slow pointer and fast pointer. Okay, once they have meet, then we are going to be making entry point to the head. Okay, so entry point pointing into the head, and slow pointer we already have. So from now what we do, entry while entry is not equals to slow, okay, we'll be incrementing our entry point, and we'll be also incrementing our slow point by one positions. So entry is entry dot next, and slow is equals to slow dot next, and then we'll be simply breaking out of this position. Okay, so when at the finally what we'll be returning our entry pointer. Okay, so that's the simple approach. I hope there is no confusion at all. So that's it for this video. We'll be seeing other problem next time.